Welcome to solverfy.
In this question, we have this setup. The collar is moving downward with a speed of 2 meters per second, acceleration 3 meters per second square. And then we need to determine the angular velocity and angular acceleration of the gear as it rolls along the fixed gear rack. Okay, so with fixed gear rack, okay, its speed is 0. Okay, so the point of contact with the gear has 0 speed. Okay, and it will be the point P, which is here. Okay, is the instantaneous center of 0 velocity for the gear. Okay. Okay, so we can determine VB. We can calculate VB as minus 0.05 omega in the J direction. Okay, so the radius of the gear is 0.2 meters, and then the distance from O to B is 0.15 meters. So the distance between P to B to P will be 0.05 meters, and then times omega gives you the magnitude of the velocity of points B. Okay, and it is directed downward according to this situation. Okay, then if you look at our link AB, okay, so we have VB pointing downward, we have VA also pointing downward. Okay, that means for the link AB, the instantaneous center of 0 velocity is at infinity. Okay, because both VA and VB are parallel. Okay, because both VA and VB are parallel. Okay, so this means that VA is equal to VB. Okay, it is 2 minus 2J meters per second. Okay, and then we can determine our omega. Omega would be 2 divided by 0.05, and then this is 40 radians per second. Okay, so we found the angular velocity of the wheel, of the gear. Yeah. Okay, next we look at the acceleration. So we can determine AO. Okay, AO will be minus alpha times 0.2 in the minus J direction. Okay, and then using the relative acceleration equation. Okay, so we have AB is equal to AO plus alpha cross RB relative to O minus omega square RB relative to O. Okay, so this is equal to minus 0.2 alpha times J plus alpha K cross 0.15 I minus 40 square 0.15 I. Okay, then just continue minus 0.2 alpha J plus 0.15 alpha J minus 240 I. Okay, so grouping everything, this is what we have, minus 240I minus 0.05 alpha J. Okay, then if you look at for the link AB, then we have AB is equal to AA plus alpha AB cross RB relative to A minus omega AB square RB relative to A. So just now I also you also need to note that omega AB is 0 because the IC for link AB is at infinity. Okay, so that means our third term is 0. Okay, then so AB is from the previous line we have minus 240I minus 0.05 alpha J. Okay, so this is equal to minus 3J plus alpha AB K cross 0.5 sine 60 degrees I minus cosine 60 degrees J. Okay, then this is equal to minus 3J plus 0.25 alpha AB I minus I plus roots 3J. Okay, grouping the terms, so we have minus 0.25 alpha AB I plus 0.25 roots 3 alpha AB minus 3J. Okay, so this is equal to minus 240I minus 0.05 alpha J. Okay, comparing components. So for the x component, so 0.25 alpha AB is equal to minus 240. That means alpha AB is equal to minus 960 radians per second square. And then from the y component, for the y component, so we have 0.25 root 3 alpha AB minus 3 is equal to minus 0.05 alpha So alpha is 20 times 3 plus 0.25 root 3, 960. So this is equal to 8370 radians per second square. Okay, so the direction of alpha, so alpha is equal to 8370 radians per second square in the counterclockwise direction. Okay, previously the angular velocity. Okay, so this is given as counterclockwise. Okay, this is given. All right, so that's all for this question.